Hey everyone, I hope you guys are doing well. And today, me and Blake will share our mathematician Abraham De Moivre, and we will share the impact that he made on the field of mathematics as well as how he lived out his faith. So, here's a little bit of background behind his life. He was born on May 26, 1667, in Champagne, France, and when he was 11 years old, he attended Protestant Academy at Sedan. And while he was there, he learned how to speak the Greek language when he was there for 4 years. And then when he was done at that location, he went to Samar with the same Protestant academy, and he studied logic there for 2 years. Even though he didn't specifically study mathematics, since there was a lack of mathematical professors at both of those locations, De Moivre still was inspired by the works of several mathematicians, including Jean Piaget and Christian Huygens. And then, when he was finished with his schooling at the Protestant academies, he and his brother moved out to London to begin their careers. Soon after their move, De Moivre became a private mathematics tutor. As he continued to work as a tutor, he would continue to find new discoveries in the world of math, and he would soon add his discoveries to the Principia Mathematica. And then one of the biggest discoveries that he added to this book was he generalized Newton's binomial theory into a theorem that he called the multinomial theorem. This theorem was noticeable enough for the Royal Society to classify him as a member. Unfortunately, despite his accomplishments, he was unable to become a professor at the local universities in London. There is some speculation that he was unable to land the job because of his French origin. Therefore, he continued to work as a private tutor. And because he was unable to work as a professor during this time, his income was rather low compared to other mathematicians. There are some stories out there that say De Moivre went to local shops and cafes to play other people in chess for money, which personally I find is rather an interesting way to generate extra income. And then on November 27th, 1754, he passed away in London, England. And then here are some contributions that he made to the world of mathematics. He was a pioneer for the analytical geometry and theory of probability. He developed De Moivre's formula, which is what we are going to prove later in the presentation. And then he also came up with Stirling's formula, which most people credit James Stirling's for, but in reality, De Moivre came up with this formula, and then Stirling came up for the constant C. And then he also came up with Bignet's formula, which we learned in class, and how it's related to the golden ratio. And then here are a couple of interesting facts about his life. So the first fact is that with his first book that he wrote, The Doctrine of Chances, he actually dedicated it to his good friend Isaac Newton. And the crazy thing is that Newton would recommend his students to De Moivre by saying that he knows these things better than I do, which honestly I think is an incredible accomplishment, having the Isaac Newton complimenting you, knowing that he knows more than he does. So that's pretty cool. And then another interesting thing was that he was able to predict his own death when he noticed that his sleeping patterns was 15 extra minutes each and every night. And then by looking at this progression, he predicted that he would die once he reached 24 hours of sleep. And surprisingly, his prediction was correct. And now we kick it over to Blake.
Hello, class. It is Blake now on the mic as we move on to the faith slide. So, De Moivre was a French Protestant who was originally educated at the Catholic village school. When he continued his education at the Protestant Academy at Sedan, this was when King Louis XIV was in power, and he issued the Edict of Fontainebleau, which happened to suppress Protestant practices and ultimately shut down that school. And after that, De Moivre was imprisoned for his Protestant faith during the religious tumult of 1685, and he was not released until 1688. And after he was released, he then moved to England to continue his education, where he presented himself as a Huguenot. or a French Protestant, despite suffering severe persecution. Throughout the rest of his life, he continued to practice faith alongside his mathematical discoveries. And below here's an image of the persecution of Huguenots. Moving on to the proof of De Moivre's formula. So, here we're going to prove that for all x in the set of all real numbers and for all n in the set of integers such that n is greater than 0, the quantity cosine x plus I sine x to the power of n equals cosine nx plus I sine nx. We're going to prove that using mathematical induction. So for a basis step, show a p of 1. And that is pretty self-explanatory. You plug in 1 where n appears, and it happens to work out. So with that, we can suppose p of k with our induction hypothesis. So the quantity cosine x plus I sine x to the power of k equals cosine kx plus I sine kx. And we have to show pk plus 1, which is what you can see right there. To prove that, we're going to consider pk plus 1. So the quantity cosine x plus I sine x to the power of k plus 1 equals cosine x plus I sine x, all of that to the power of k, times cosine x plus I sine x. And using the induction hypothesis, we can substitute the cosine x plus I sine x to the power of k with cosine kx plus I sine kx. And then after that, you just distribute the foil it, and you get this long piece right below that. And then, by trigonometric identities, I believe it's the subtraction identity, we get finally cosine k plus 1 times x plus I sine k plus 1 times x. And that's equal to the quantity cosine x plus I sine x to the k plus 1. So therefore, by mathematical induction, the formula is proven. Personal thoughts. Do I think that De Moivre is a good role model as a future mathematician? Yes. I respect his tenacity, not only as a mathematician, but as a man of faith. He was inspired by famous mathematicians, and he was determined to understand complex concepts in the world of mathematics. And he never gave up his faith, or what he believed, despite the prosecution. It just really shows that he cared about both math and about his faith. He had this never give up mentality, which I highly respect. He was never formally taught mathematics, but that did not stop him. And he made it to the point where he was praised by his mathematical heroes for his work. And this is definitely inspiring to me as a future mathematician.
And then here are the sources that we used for our presentation. Thank you, guys.